Hi, welcome to another episode of the Chris and Lisa Show. I'm Lisa L. I'm a certified financial planner, and I'm going to introduce to you Chris Heeman. He is a discretionary portfolio manager. He's been in the industry working hard since 1993. He specializes in volatility investing. And today, we want to talk about using math to measure the meaningful. So, getting some meaning out of these numbers, right, Chris? So, let's talk about the math.
Well, the math is always a fun topic for me and not for everybody else. I don't know if anybody else had their favorite topic in high school or favorite class being math. But after we've been talking about all these different things, I thought we would start with diving into how do we actually make some of these decisions and how do we actually measure our successes appropriately. In finance, math is the most important language. Math is just like any other language you learn, whether you're learning to speak French or German or Japanese, right? It's a whole language to itself, and we make a lot of mistakes out there because our basic math skills are not intuitive enough, right? We don't actually have the right math skills unless you're taught them. So we can make some really interesting mistakes. I got a great story that I'll share with you today about how averages work, but the idea behind all of this is how do we actually measure the amount of risk we're taking when we also make investments so that we don't get caught up in too much in the end result. So, and then a story I like to share is look, if you've got $1,000 and you go to Vegas and you bet it on Black 18 and it pays off, right? How do you measure how risky that was since you found out the result and you ended up with a 32 to 1 winnings? I mean, you win $32,000 if you make that bet. If you're a millionaire, that bet is not risky. But if it's the last $1,000 in your pocket, that's a risky investment. So we have to have a way in our investments and a way to look at things in the world, investment wise, to make sure we're making appropriate decisions. So I'm going to start off with some basics. Okay, we're going to talk about some things from our high school math that might make people cringe, but hopefully I can do and have a little fun with this. I talk about these things all the time with clients, okay? Because people forget and get confused on what these things are, okay? So we've got these words up in front of us, right? These are the statistical terminology. The word at the top, mean, is the average, okay? That's the one that we use all the time. What is your average rate of return? What's the historical average rate of return? What average are you trying to achieve? After I'm done going through this, I'm going to tell you my little story here. But when we use the word average, what we mean is the word mean. Mean is the average. So here's a quick example. You got a group of numbers. When you add them up and you divide by the amount, you get the average of 5. Okay? But that doesn't tell the whole story. That's a blend. That's what I call the soup result, right? Can't really carve that out. It's not like a pizza where I can take the pineapples off my pizza if I don't like them. Like everything is blended in that average. So we don't know about the 9. We don't know about the 1. We don't know there were 2 3s in the group. We really don't know a lot about the story. Okay. The median is the absolute middle of the pack. When you organize your numbers, as we see here in blue, from 1, 3, 3, 6, 8, 9, the average, the median, is actually 4.5. It's pretty close to the mean, but it's not the actual result. It's the one right in the middle, what falls on either side. Okay. Now, my favorite statistical term that nobody likes to use is mode. Now, mode is very easy one to remember. It's the one that is the most often occurring number. Okay. So if you have a group of results, the mode in this case is 3. So mean, median, and mode. Okay. Those are the 3 things that I use a lot on these numbers. That most people, they just stay with this average because that's what all of the reporting shows. That's what all of the media talks about. That's all the numbers is always up here in the average. It's the easiest thing because it distills down to one number that we think tells the story. Now, the other thing at the bottom of this is the word range. Okay. The range in this case is the number 8. That's the actual result. But what range, what we really want to understand is is the range of our numbers that we have in our in the amount of numbers we're looking at. So from 1 to 9, the range is 8. Okay, so there are 8 opportunities or 8 different numbers that could show up in this range. Range, I'm going to change the word, and also you can use it. There's a word called dispersion. So dispersion is how many numbers did I get, and what is the range of those numbers? Like if I have 5 numbers or 15 numbers, how did those numbers get dispersed? Okay, because when we get into some of the other things about what we use with these numbers to help us make decisions, we have to understand we're looking at a big collective of results. Now, those collective of results can happen over years, months, weeks, days. It all depends on what we're trying to distill or trying to figure out. Okay, those are the basics. So far you're with me?
Absolutely.
Okay, it's not the most exciting conversation, is it? Back to math school, right?
Yeah, back to junior
class.
high.
Yeah. Nobody likes to do this stuff, but language is really important. We got to understand the basics. So when we talk about mean, I want to tell you a story about how tricky numbers can actually be, because they can confuse people even at the higher levels. Okay, in the late 1940s, the U.S. Air Force was having a huge problem with their pilots crashing. Okay, it was the dawn of the jet age. Planes were flying faster, right? And there were all these accidents, basically. So the government takes an event and says there's 2 things. There's an incident or there's an accident. Okay, and they were trying to figure out what was going on. And they spent a lot of time sorting through the information, and it came back that they were putting pilot error as the number 1 thing, okay? As the most common reason for crashes was pilot error, okay? So after a bunch of times they looked at this, they were thinking, how can our pilots not make all these errors, okay? So they turned their attention into the design of the cockpit, right? What was happening inside the cockpit and how it was designed. Well, back in 1926, Army engineers were designing the first cockpit, right, that pilots were going to fly in. Okay, they measured the physical dimensions of hundreds of pilots. Okay, they measured them in all these different areas, and they created an average size cockpit. Okay, so that worked for quite some time. And then in the 1950s, after all these pilots were crashing, they went back and they did this study at the Wright Air Force Base in Ohio. And they measured 4,000 pilots over 140 dimensions. Okay, that included thumb lengths. Like, what is the distance between the tip of your thumb and the base of your thumb? Okay, and the idea was that they would take all of this and they would calculate all these dimensions and they would improve cockpit design. Okay, and they had this guy, he was a 23-year-old scientist. His name was Lieutenant Gilbert Daniel. Now, he was kind of a skeptic. Okay, and he kept asking himself this simple question: how many pilots were average? Okay, so here's what the Air Force did. They took 4,000 pilots, they measured them on 140 dimensions, right down to the thumb, and they rebuilt cockpits based on the average size. So then Gilbert comes along, and he takes 4,000 pilots, and he measures their dimensions, and he puts them in a big chart, and he expands the average by 30% on either side. So, for example, okay, just to get a bigger range of numbers, right? When he did this, he said if you're 6 foot, right, or from 5'9", we'll say, he made the height on the range being able to be 5'7" to 5'11". Like he made it so it was more expansive, so he could capture by 30% of that range. Does that make sense so far?
Yeah.
He could capture more of the amount of pilots of the 4,000 that fit into that average. So he increased the average, okay? Increased the average. So here's what happened. You think you can guess?
Yeah, I'm guessing the numbers were way off.
He found there were 0. Absolutely no pilots of 4,000 fit the average.
Right.
Okay. Now, As he brought down how many dimensions, okay, one of the most amazing things he did is he found out that nobody fit all the way down to 4, okay? So he took this average range on all these different dimensions, right? And he couldn't find anybody that actually would have an average length of feet or legs and the average length arms. You could have the legs, but you could never hit the arms. People aren't built on average. Average is a number we use mathematically. It is not something that exists. Okay. He found out that if he could pick just three dimensions, okay, say neck circumference or the circumference of your thigh or your wrist, just pick any 3. Less than 3.5% of all the pilots averaged in those 3. That means 96.5% couldn't even meet the average dimensions of 3 of those ranges. Okay. So, in essentially, what was happening is that pilots couldn't function inside an average cockpit. Too big, too small, their eyes were too far back, too far forward, heads were down, heads were up. They couldn't do it. Okay. You've designed a cockpit to fit an average pilot, and you've actually designed it to fit no one. That's why crashes were happening. There is no such thing as an average pilot. Now, incidentally, you want to know why your car has an adjustable car seat? It comes from this study. The first adjustable seat came from fighter pilots. Okay? So what they started to do is they started to allow inside the cockpit things to move. They could move the seat, they could adjust the seat up and down to get closer, they could go up and down. Everything we have in our car today that in regards to fitting someone to make it more custom came from this study. Not everything, but a lot of things came out of this study. Okay? So there's my story. It talks about what is important. Going back to our number, the average. The average doesn't exist. There's no such thing as average. We use it, but it doesn't mean what it means. Okay? What we're trying to figure out is we need a number. We need something in math, and we need something in investments that will help us make better decisions. So far, so good?
Yeah. And great story, by the way. That's great.
Yeah, it's a great story. I love that story because I always tell the joke when I do these in seminars and stuff. If you've heard about the economist who drowned in the river with an average depth of 3 feet, right? So what I'm going to do is I'm going to make a leap. I'm going to go from where we are now with the basics, and I'm going to jump into talking about standard deviation. Okay? It's a little higher up on the mathematics here. So what we got is a picture of what standard deviation looks like. Okay, I'm just going to adjust it on my screen so I'm staring at it while I'm looking at you. Okay, so what we're looking at is what is a standard deviation? Well, a standard deviation is when we're going to take all those dimensions, we got to figure out, like this guy Gilbert figured out, is that only 3.5% of the pilots actually fit into this huge range. So down here we've got this one standard deviation. One standard deviation means that 68% of the range will fit into it. Okay? Two standard deviations, meaning one move to either side and then another move of equal distance to either side from the middle, from the average, right in the middle, the median. That's 95% of all the numbers that exist will fit into that range in 2 standard deviations. Then you get up to 3 standard deviations. This is what we call tails. See how this chart works? This is a Gaussian distribution curve. If you want to feel comfortable going back to math class, I'll talk a little technical on you. Okay, so what happens is all the numbers that we collect when we are measuring things, measuring Air Force pilot dimensions or measuring historical returns, they will fit into something that looks like this, okay? And out here are these things that we say only 1.3% is going to be outside of this, okay? So when you look back in here, 68%, 1 standard deviation move. Well, what is a standard deviation, okay? What are we looking at, okay? Let me just reshare that. Here we go. So it's important to understand that when we're looking at things, we have to understand what it might mean to us. How is it applied to us, okay? So here's how it can apply, same curve, to investing, okay? Just adjust things here. Okay, so we've got the same looking curve, okay? we got a $50 price that's currently in the middle. Okay. And on outside of either side is we've got that 68%. Okay. So we got this little thing called volatility that we've talked about, a mathematical way to measure the dispersion. So how many different returns can fit inside of the higher volatility goes up. If we have a higher implied volatility, then more types of returns can fit inside one standard deviation. Okay. So if you look at this, it says one standard deviation move. You take your $50, your middle, you multiply it by the 20%, which is your implied volatility, and it tells you $10 on either side of your middle. Okay. That is the range in which you could end up with a result between $40 and $60. Now, in investing, volatility, which is what I love, kind of tells me what might happen over 30 days. As volatility expands, over the next 30 days, my range can expand, my opportunities to buy low, my opportunities to buy too high and watch it drop, those are all increasing. This is a good one to talk about because yesterday we had the volatility index spike 30%. Okay. So it went up pretty quick and all of a sudden everything changes. Okay. So that's how this can apply to the basic maths. We can take those mean, medians, and modes. We can use this range of numbers. We can do all of this calculation and we can start to distill down just like this Gilbert guy did and say, look, only 3.5% of the pilots even match 3 of these dimensions. You don't have a cockpit that works. When it comes to investing, we can start to understand what is our expectation of our return and what that can look like over time. When volatility goes up, our returns can increase, our ranges increase. When volatility comes down, right? There's the simple part of it. But can we get to a number? Can we get to something mathematically that can help us make decisions? And we've talked a lot about behavioral finance and we've talked about all these different things. What I find, like a lot of things in life and a lot of industries, is finance has got the same problem of measuring the measurable versus measuring the meaningful. What I mean by that is that when you get numbers, it's fun to measure all sorts of great things. Okay. And sometimes it doesn't tell you all the story. One of my favorite sports that tells you too much information is baseball. Okay. Baseball is a statistical driven sport. And you can get a little carried away because we really don't care that the success of a left-handed batter versus a left-handed pitcher on a rainy day versus a dry day versus whatever, right? You're getting a little too specific. So that's measuring the measurable and using the measurable. Just because you have numbers doesn't mean that everything you measure has meaning. Okay. So we want to find something that can help us with meaning. And one of the big things that is thrown around today is the Sharpe ratio. Okay. Now, I don't know if you've heard about the Sharpe ratio, depending on your experience in finance. Okay. But the Sharpe ratio is a way that we can measure a standard deviation or measure an investment that includes risk. Okay. So suddenly we can start to measure our success and include how much risk we took on and how much volatility we experienced with that investment. That's step one. Okay. Now, I'm not a huge fan of the Sharpe ratio. Okay. But it's used a lot. It's very, very dominant in our industry. Okay. So here's a little definition of the Sharpe ratio, right? It expresses the relationship between performance of something, a scheme, and its volatility, meaning a higher ratio signifies a relatively less risky investment. So if you have a 15% rate of return with a negative or 1% Sharpe ratio, it might mean that you're taking on too much risk. But what if you could get that 30% return with a 30 Sharpe? The Sharpe ratio is the holy grail for a lot of portfolio managers. They want to say that my Sharpe ratio is low because it means that your returns are risk adjusted. So I've factored in how much risk I've put you in and how much risk you're willing to take on in that investment. What does it really mean? Okay. Again, going back just to use that analogy, taking $1,000 and betting it on Black 18 is an incredible risky bet. Now, we know that intuitively if we only have $1,000 left, but how do we take a number? How do we distill down risk to a number? Okay. And the Sharpe ratio is a way to do that. I'm not going to go through the calculations or the methodology, and all of the nerds out there that are loving the math. If they want to have that, we can talk to them separately and they can call me because I love this stuff. Okay. But for me, there's one more number that means even better. Okay. And it's called the Sortino ratio. It's my favorite. Now, the Sortino ratio is a Sharpe ratio. The math is very similar, but it's slightly different in that it's calculated by removing downside risk. Okay. So here's where the Sharpe ratio can go a little bit skewed. It includes the volatility to the upside, which means it includes success. Okay. So if you have a number like 10 as your rate of return or your average or whatever you're going to use to measure, and you have a result which is 3 times that size, which is 30, okay, that's a huge volatility. Okay. And if you have a negative return of negative 10, okay, your upside is bigger than your downside. But the measurement, the volatility, the difference between the middle and the median, right, is twice as big to the upside it is to the downside, and it can really skew Sharpe ratios. Now, I'm an options guy and a volatility guy, so Sharpe ratios don't really work for me. There's a whole lot of reasons. Again, maybe another session in the future. But what I like about the Sortino ratio is it removes the upside. The upside is what we're trying to achieve. The upside is what we want. It's the downside we want to try and bring in and say, well, if I make this investment, what is the predicted downside and what could be the benefit of owning it? To me, the Sortino ratio is a better measurement for investors because it doesn't get all whacked out when you get success. Okay. It only gets its number really to change when your downside is big. Does that make sense?
Absolutely. Yeah.
Okay. So far I'm making sense. This is not too bad for math class.
Yes. No, it's good.
Yeah. So the Sortino ratio is reported on pretty much all the products that we buy and sell in the market as investment people, right? Like there's a Sortino ratio, and you can go and find it on the internet. So when people are looking at things and they say, oh, look, this is a great investment. It has an average rate of return for the last 15 years of 12.5%. Okay. That doesn't tell you the story. If you go back to the very beginning and we look at our mean, median, and mode, okay, taking a look at historical performance doesn't tell you anything. It tells you what the result is if you went through that journey for 10 years, you didn't deviate from your journey at any time. It tells you that you could look back today and you could measure. So one of the ways that I've done this, to give an example, is if I have people come to a seminar and I say, so I need you to do me a favor. I'm having an argument, right? That how far away your house is from the seminar, right? And I would like somebody to measure the distance and report back to me, and I'll get a volunteer. And when the volunteer puts up his name, I said, thank you very much. And I walk over and I hand them a 30-centimeter ruler. Okay. So why do I do that? Because they go, what do you want me to do with this? I want you to measure, right? I want you to measure how far it is from here. And would you use a 30-centimeter ruler?
No.
So I asked them, right? How would you measure the distance between here and a long distance? And everybody will tell you the same story. Well, I'll just zero my kilometers on my car and I'll drive there and I'll look back and I'll tell you how far I went, right? And I said, that's exactly what historical performance does, is it tells you after you've experienced it, okay? It tells you how far you would have come. It tells you a little bit about the story, but it's really not the story of what you might experience. What you want to know is, what's the weather? What's the traffic? Is there obstruction? Do I have to, are there bumps and potholes? And is there a road that's gravel? And all of that will tell you all about your journey. And you want to know going forward, is that something that you're willing to experience? Okay. And there are numbers in our world of investments that can help you with that. And the Sortino ratio to me is one of those numbers that I like to get people to focus on. instead of doing the Sharpe ratio and getting caught up in Sharpe ratio, I like to get caught up with the Sortino. So here's what it is. The Sortino ratio is similar, except that the Sharpe ratio uses standard deviation in the denominator. The Sortino uses a downside deviation. It just captures only the downside, okay? And looking forward, if you were to try and make an investment, is it suitable for me? The Sortino ratio starts talking about the experience you could be having, okay? Now, we're here to help clients sort that out. I don't expect them to go out and be able to say, oh, the Sortino ratio is this, and that makes it great. What I wanted to try and accomplish today is to say, look, the math can be really misleading. We get caught up in the wrong math, okay? My favorite number is mode. Why? I don't care what your average is. I care how often the number occurred. The number occurred. So I'm a baseball nut. Same thing. Don't care about the average hit. I care about how many times gets on base. What is the most often occurring number? If the most often occurring number is a 3 and the average is a 6, I've got a story that is starting to develop. Can you see that?
Oh.
If the average is a 6 and that mode is a 3, how did we get so much more to the upside at the average than we have at the mode? Something happened, okay? And when that something happens, it can be one time. It could have happened one time in 10 years, and it might not ever happen again, but the average doesn't tell you that story. It can actually lead you in the wrong direction. It's really important when we start getting into situations where the markets start looking like this, okay? Now, I threw this up before, and in this chart, what we're looking at in blue is the S&P 500 over time, and underneath, we're looking at my favorite volatility measurement, the VIX, and how the VIX explodes to the upside and the markets come down, right? So what we're trying to do is we're trying to understand how much risk we're taking on when we're taking on an investment. What is the expected return of that investment over time? What does the journey look like? And can I handle that? So you know what we're really doing here, Lisa?
What? What are we really doing here?
We're putting in that measurement at the fair, at the Stampede, that says you have to be this tall to get on the ride.
Yeah, that's
Okay?
a good one.
We're saying if you want to get on this, you have to be this big. Okay? You have to be prepared for something, don't you? Okay? These are numbers that can help us illustrate to clients and to get them to understand this thing that you think is going to be fun. It could have some very delirious effects to you. Like you could end up sick. Okay?
On the roller coaster ride. Yeah.
You're getting on the roller coaster, you know, the mind bender at the West Edmonton Mall, right? That was the big one when I was growing up. Everybody wanted to go to the mind bender.
Yes.
So using math this way it gives us the ability to look at things differently and not get lost in some of the marketing that is out there. I'll pick on them, the industry for a little bit. We have a tendency to market, and if you follow marketing, it's keep it simple, stupid. So they're trying to use numbers that are easy to understand. Everybody understands average, okay? But what I've hopefully done today is illustrate average doesn't exist. Average is a mathematical concept, okay? And fighter pilots found that out the hard way, and the U.S. Air Force made some major adjustments, and now you can adjust your car seat so that we don't have to be 5'11" to drive the car safely, okay? That's some of the effects of looking at things differently. And when you get into investments, when you're looking at, well, this is a great looking return, it looked good over time, but tell me about the risk that I'm taking. What is the journey like? And when we measure risk, remember, risk is a lot about standard deviation, which is simply what is the range of the numbers I could experience. If you can handle this big a range, then you're good. If you're this tall, you can get on the ride, okay? But if you can't handle that big a range, if you like things that don't change a lot like that and dramatically like it did yesterday for all of a sudden, then this is not the ride for you. And maybe we need to find something else that fits you, okay?
No, Chris, this has been amazing. I really appreciate this. It's so important. Even with all the numbers the media throws out, not even related to the stock market, even COVID or any political subject. There are so many averages and statistics,
yeah.
and it's so important to dive deep. And exactly like you say, like just because we can measure something doesn't mean it has meaning, right? So
That's right.
I think this is lost in our news today, but I really appreciate this talk. It's a great reminder. It's perfect for investing, obviously, but even for other areas in our life. So thank you so much for this.
No problem. It's always a pleasure. I look forward to our next conversation.
Yes, thanks so much, Chris. Have a good day.